All right, ladies and gentlemen, hello and welcome to a very special episode of DM Radio, a virtual summit today. Yours truly, Eric Kavanaugh here. Very excited. DM Radio starts in 30 minutes. Before that, we have a couple presentations from experts in the field. Before I get into that, check your local listings. Future Proof, the world's first made-for-TV webinar series. That's what I call it. We now have our own time slot in Washington, D.C. You can also catch us in Atlanta, and Cincinnati, I think it is, and Los Alamos, and lots of other places around the country. Down to a science, how to train AI models. So this is brought to you by 7W Data. Of course, that's Eve Mulkers and DM Radio. We have several guests for you today, including Brian Raymond, founder of Unstructured.io, taught me a lot about large language models. Lauren Burke is joining us, a data scientist from CoverMyMeds.com. Just down the road here, I'm in Pittsburgh. She's over in Columbus. And David Cooperberg, as well, is going to join us from Alteryx. Thanks to Alteryx for their sponsorship, helping us bring you this content free of charge. And with that, I'm going to stop sharing and hand it over to Brian Raymond of Unstructured.io to talk to us about training AI models. Brian, take it away.
Thanks for having me. Let me kick off my screen share here for everybody, and we're going to take about 10 minutes to talk about large language models and emerging data architectures here. I'm founder CEO of Unstructured. We're a 13-month-old startup. We are just focused on ingestion and pre-processing of natural language data for machine learning. And so what's that mean in practical terms? We're helping you take everything that's stored in S3, Azure Blob, SharePoint, wherever that natural language data might be, that's in a long tail of file formats, and render it into clean JSON that's ready for machine learning pipelines. However, there's a lot of complexity there, and there's been a lot of changes over the last 12 months. And so we're going to walk through that. Historically, in natural language processing, you've had two big challenges economically that have hindered adoption. One, NLP models, expensive. You needed expensive labeled data to train. You needed lots of small models that were orchestrated into complex pipelines. But then also, before you even got to the models, you need to spend a lot of money building custom pre-processing pipelines to take and get absolutely clean data, pristine data to feed into those pipelines. And so that really held back adoption over the last 5 years and 10 years more broadly. With LLMs, and especially with like ChatGPT 3.5, DaVinci, and then all of the open source models that have emerged since then, they've changed the economics on one of those problems. So they've lowered the startup cost for inference pipelines. You don't need as much labeled data just to get started. You don't need to orchestrate complex pipelines. It's much easier to get up and running. But on the pre-processing side, you're still spending a ton of money to take your private data, or the data that's in, say, PDFs or PowerPoints or HTML, and get it into clean JSON. What we've seen over the last 12 months has been kind of an entire rewriting and upending of the data architecture and how data flows, and it's been really interesting. So up until about last December, you'd take all of that data, you'd pre-process it. We have our logo there, but you could build custom pre-processing pipelines, and you'd feed it through a complex machine learning pipeline and store structured data in a graph database, typically. That began to change after ChatGPT was released, because these models were capable of a whole lot more. And so rather than lots of small models, you had one big model. And so in November 22, everyone said, hey, there's a lot that's just stored in memory that's encoded into these models themselves. And so let's just ask ChatGPT to do all sorts of cool stuff and use what's in memory. By February, as an industry, everyone realized, you know what, this thing doesn't know anything recent and hallucinates like crazy. How do we start changing that, right? And the industry started to zero in on an architecture similar to what we're seeing here, that's predicated on kind of two pieces. One, a vector database, so putting validated recent relevant data into a vector database, so those JSONs with something called embedding pairs with them, so numerical representations of that text, and then also allowing those models to use a retrieval method. The predominant one is called retrieval augmented generation. Essentially, to go check out from the library new information from that vector database, bring it back, insert it into that prompt, and then to force that the response from that model to be grounded on that information. And so folks were building APIs, grabbing data from the internet, jamming them in, dumping it all into the vector database, saying, okay, we think this thing might actually work. By late March, you started seeing people playing around with agents. What you also saw was a company that recently was acquired by Databricks called Mosaic ML going bananas as well. So you saw kind of called Mosaic ML. And so at this point, you saw kind of two ways of engaging with these LLMs. One, these are a lot bigger, a lot more complex models, difficult to interact with, but companies like Mosaic started to make it easier to encode your data into those models through fine-tuning or pre-training. But then the vector database market went nuts. We've had about $500 million pumped into the vector database market over the last 6 months, because a lot of folks said, hey, I don't have to go through all this complex training, even though companies like Mosaic are making it easier. I can just dump it, I can pre-process it, dump it in a vector database, and just let the LM go check books out of the library rather than actually going to school itself, right? And so there's a lot of hype around generative agents around this time as well. No, you don't hear about as much over the summer because after an enormous amount of hype in kind of the March, April timeframe, they realized, hey, these things actually are really, really hard to get work in a reliable production grade setting. And so, where we're at today is one where everyone's just kind of realized, hey, the LMs are great, but they aren't very useful for a lot of business processes unless they have access to recent, relevant, and validated data. The models themselves are generic. They're not. They don't know anything about your company. 2, they're frozen in time, and 3, they hallucinate like crazy. And so, how do you counter that? Well, this architecture helps you with a lot of that. It's not the only option, but it's a very fast and easy way to get going. And so, the challenge now, the bottleneck that we're helping with, and that a lot of folks are focused on right now, is like, how do you get that recent, relevant, and validated data into the vector database or teed up to encode into the model? And that's this long tail problem of, we as humans are creating natural language data all the time in dozens of different file formats and an infinite number of document layouts, and it's being stored all over hell. And so how do you go find it and transform it and refine it quickly and reliably, so that you can actually walk and chew gum with LLMs at the same time, so that these LMs can be inserted into, generative tasks and information retrieval tasks across a wide range of business functions. And so, stepping back from a market perspective, you're seeing dozens and dozens of companies emerge that are offering packaged solutions of this RAG-based architecture under the hood, where they've made a lot of the micro decisions for you and make it easy. Then you've also seen a huge amount of companies like ours that are key players in this value chain that's starting to look a bit more like what the structured data value chain looks like, but there are some key differences as well. And so, hopefully that was helpful in terms of providing an overview of the key trends over the last 9-10 months or so, and then also some of the key challenges that we as an industry are facing over the next 6 to 12 months and beyond, in productionizing a lot of these compelling prototypes.
Yeah, and you use this really fascinating concept when I talk to you, Brian, that you refer to them as anchors of truth. I just think that is really a very powerful term, because the problem, and I've talked to a number of people who know a lot about these LLMs, including a guy who was asked to work for OpenAI, and he said, look, you guys need to embrace entropic models and understand the importance of recognizing the power of entropy, which is reality. It's not going to go away. And if you don't have moorings for these things, they're just going to kind of float off like hot air balloons up into the sky. So you're the one who kind of woke me up to this reality that you need these moorings, basically, and that's what you're publishing in your vector database. And of course, what you folks are doing, you could take any unstructured data, any PDF, a letter, an email, or whatever, strip out the semantic meaning, and then persist that as an embedding in a vector database, correct?
That's exactly right. And so what's going on is you're reducing everything into a JSON or a Markdown kind of native, and then using an embedding model, the three kind of most popular ones that you can find on Hugging Face, Cohere, or OpenAI. And what those do is take chunks of text and convert them into vector strings. And so anywhere from like 700 to 2,000 number strings. And then on the other side of it, there's Jerry Liu at Llama Index, Harrison Chase at LangChain, and a bunch of researchers doing fantastic work on developing new retrieval models, which are really, really good at taking the prompt. Hey, give me I have these ingredients in my pantry. What can I make for dinner tonight? Encoding that into numerical form, matching that to relevant data strings, right? That's in the vector database, pulling all that back, offering it to the LLM as a reasoning agent who can consider all of that taken together, and then force that LLM to produce a response that incorporates those moorings as we were talking about it, the truth, right, that you're bringing to it. And so that's the really exciting moment that we're at today.
Yeah, that is very, very cool stuff. So you're using the LLM for really what it's supposed to be used for, which is providing context in the form of words to describe the facts which are stored in your vector database, correct?
Yeah, you're telling your intern, hey, show your homework here.
That's good. And it's also the explainable part, right? Because, I went to a Reuters conference in Austin, Momentum, I guess about a month ago, and one of the guys there was saying, yeah, explainability is out the window. And I'm thinking, well, we better figure that one out, buddy, because it's not going to be very usable in the corporate world. And, corporations are very concerned about this. CEOs are very concerned. They've got the privacy people ringing their bell, the compliance people, hey, don't you dare use this stuff. And the CEO's like, what are you talking about? This new powerful technologies I can't use. That's not going to win with most CEOs, but we got to do something. So there's going to be a whole governance side of this to come in. Well, Eve, before we spend too much time chatting, let's bring you in to talk about what you're seeing, and you're the master of the prompt. So Eve Mulkers, and thank you so much, Brian. It's really, you've blown my mind with this stuff. I love it.
Thanks for having me.
Yeah, take it away, Eve.
Yeah, thanks for that, Eric and Brian. I think Brian already did the good announcement and preparation about large language models and where we are. So what the heck are large language models, and how do we talk to these models? How do we use them? It's about prompting, as we call it. But to give some background understanding the large language models, it's an agglomerate of all the information that we find online. And it's in fact a kind of prediction, a model that predicts the next word possible whenever you give an output. That's how the large language models in a simple way do work. They are based on the foundational models which were built earlier. I think Brian already mentioned those as well. They were rule-based approaches, and they were manually trained and are now used as being the foundational models, where large language models are a bit more self-learning compared to these foundational models. What we see coming now on the large language models are domain-specific large language models. And what does that mean? They are trained depending on a certain domain. For example, industry, for example, insurance, customer service, name it. They are well familiar with the taxonomy used in that specific industry. So their reasoning is really tied into a certain industry. What do we see? Everybody knows ChatGPT from OpenAI, but there are various other open models that are now available. For example, BERT is one of those developed as well by OpenAI. GPT-3, the predecessor of the GPT-4, which is currently used on OpenAI, and XLNet, which was developed by Google AI. There are some more specific large language models which are developed. This is the Palm model developed by Huawei, Cohere, which Brian already mentioned before, developed by Eluder AI, and Dialog GPT developed by the Microsoft Research Department. So you see, these are just a few of, I think, more than a few hundreds of the large language models which are available on the market. And why are these large language models so useful? We listed about 6 of the most useful cases for using large language models. So if you're interacting with these models, by prompting. They can help you with summarizing a big blob of text. For example, I threw in a PDF recently summarizing a 200 pages PDF, and it's easy to say, hey, just summarize it, give me the key highlights, what are we talking about, and you can start chatting with that PDF. You can use it for brainstorming. Brainstorming is wherever you're blocked into a certain area and say, what will be, for example, which next webinar will we host? What are the trends that we see on the market? And you can start chatting with that large language model and get some ideas for your next webinar to host. Another part which is very interesting is the synthesizing of some of the text that you bring in. So really, again, understanding what you are talking about in a better way. And of course, where we see a lot of application of the large language models these days is the writing. So a lot of content is being generated by AI, name it LinkedIn posts, Twitter posts, blog articles, essays, name it. They are pretty proficient in there, and we see some of the platforms that are using various large language models together to become more humanized than compared if you just use ChatGPT. You can identify that it is written by an AI based upon the wordings and the following of the wordings in such a way. Another interesting part is the coding where you can use it. For example, you fire off to a ChatGPT, give me, I have 3 tables, client, product, and invoices, for example. Create me an SQL to link the tables together. If you are not specific enough, you will get questions from the model in such a way where it says, hey, give me the key fields on how I need to combine these tables. So they're pretty smart in interacting with the prompt you are firing off. And of course, reformatting. If you have a paper which is not so clear, big text, you can make it more accurate. You can do it, you can format it. So just take the text and say, reformat it as bullet points, make it more accurate, more precise, make it shorter, make it longer. And these are already some of the tips that you can use in your prompting. I explained it a bit already. The role of prompts is interacting with your large language models. How do you talk to that and how do you get a response back from the large language models? We call it the mastering the art of the prompts. It's pretty specific. If you're too generic, then very likely you won't get the answer that you are expecting. One way of just informing the large language model on what you want to get is a way of calling it sequencing or chaining prompts. Sequencing is a way of putting all your instructions, all your questions in one big blob, in one big question. That is sequencing. I'll give some examples later on. Chaining prompts is in the same way, but you fire off a question, you get an answer, and based upon the answer you get, you fire off your next question. This is very useful when you're doing analysis. For example, you upload a data set to ChatGPT, you start analyzing that as you typically do as a business analyst when you're looking at a report or firing off a query against the database. What is very important is the context. So you can make the large language model a bit more aware of what you are talking about. And that means you can provide the role that you want the large language model to play. For example, you are a digital marketeer, you're an industry analyst, you're a data analyst, you're a CIO, CEO, name it. You can provide a role, and then the model will act in a different way, use a different type of wordings depending on the role you provide. Tone of voice, that's a very important one as well. Call it humorous, call it informative, conversational, funny, and various other examples will follow later on. And then one of the things is that you need to specify as well the topic that you want to discuss. A thing that is very often forgotten are the types of formats that you can ask for a large language model to put out, and some more examples later on. I'll start with the end in mind. You see, you can ask the large language to give the output in a JSON format, in a table format, a graph format, things you wouldn't expect from a textual large language models. An interesting one, but that is being achieved by using some of the plugins that are Mermaid flowcharts. Mermaid is a kind of language that allows you to create flowcharts. It's an interaction, it's a type of constructing words with arrows and so on, and you get this visualization, what you see here in the yellow part. We mentioned before the code blocks, what you can get as an output. For example, give me a query to combine 3 tables. I want to write a part of Python code to do classification of a data set. And of course, you can get the example output just in plain response as you would write an essay. Tone of voice, I mentioned before, I just highlighted 4 of them. To give an idea on how you can specify your prompt. You can call it inspirational, humorous, authoritative, or empathic. Now, what is the importance of task-specific language? So you see, if you provide to your prompt that you are discussing or asking a question related to advertising or customer services, or news reporting, you will get the different wordings on your response. So you can ask the same question, but depending on the contextual surroundings, you will get different wordings and different phrasings of your answer. Another thing to keep in mind is always with the end in mind, who are you talking to? Who is your audience you're talking to? For example, if your audience are children or teenagers, the wordings again will be different in your responses. For example, you can put in your prompt, just explain this topic as you would explain it to a 5-year-old, and the wordings will be more simple and not so in detail as we as adults and grown up master in the language we are using from day to day. As you see, I just mentioned the certain tone of voices and the type of audiences, but if you're talking about subject matter, you see that you can combine the tone of voice and the audience, what you are talking about. So for example, you formulate your prompt for psychology or with a politics background, or more specific towards technology, and then you get again the different type of answers. Previously, I talked about the sequence prompting and the change prompting. The sequence prompting, we call it as well mega prompting. That is just providing a big question with as much as possible specific definitions of what you are trying to achieve. And we'll step into an example later on. Well, here we come into more the field that we are talking all the time at Inside Analysis and DM Radio. That is data analysis, and how can you use prompts and chaining prompts in doing your data analysis. For example, you can ask what is the overall trend of sales in the past year, and you get the answer. Next on that, depending on the answer you get, it will be very generic because your question is pretty generic, and then you break it down into the follow-up question. Can you break down the sales trend by product category? Are there any seasonal patterns in sales within each product category, and so on and so forth? Typical what you do in some business analysis or getting requirements right. If you're talking to a business person and you're trying to build a report, you need to understand at which level of granularity and detail that they want you to create the report. And of course, these large language models are insanely helpful on doing these type of analysis. A specific framework, what you can use to be more specific in the questions you're asking is the RTF role, task, and format. And you see, for example, you can ask the model, as a digital marketeer, which is your role, write a persuasive email in HTML format. That is a task you ask it to do to promote a new product launch, and that is the format you're requesting. Other are the context, task, and format, and then the ROSCEF as well, which are very extensive ways of specifying your question. So for example, if you see sequence prompting and chain prompting together, you have an example. For example, here we formulated a prompt. You are a writer and an expert in productivity and how to improve people's lives. Your task is to give the best advice when it comes to improving lives, reaching goals, and getting more productive. Imagine and write an informative passage about how to build better habits. Take inspiration from the following research, include the seed words, and then you see all the details that we provide to the prompt to get to the answers. And this is a very good example of sequence prompting where you create the context, the expected behavior, the expected result, and all the type of details that you can formulate to get a certain answer. And an interesting what mostly I didn't see in any kind of prompting is you get an answer, but if you get that answer, you can make the large language model think in a certain way. So you can ask it, let's think about this passage using an example, and you give it an example. Or for example, in a reverse perspective, or just depending on the answer you're getting, you can ask it to give it a response into a bigger context or using analogies. And it's tracking to see that depending on the context or some other environment that you are providing, you get different type of questions. So that allows you to understand a certain passage in a better way. For example, if you ask it for a historical standpoint, then you get the history of that certain passage or the topic that you're talking about. Things which are very helpful, and specifically on ChatGPT, these plugins are called GPT Design and AI PRM. AI PRM is a collection of, I think, more than 2,000 prepared prompts, depending for finance, for digital marketeers, for finance, depending on that, all prepared prompts that you can use. GPT Design is in the same way, but it's very targeted towards digital marketeers and helps you on formulating everything that you need for product launches, email sequences, name it, what you want to achieve in digital marketing. GPT Design helps you on defining your unique selling, and depending on the context that you set up in GPT Design, you can get all the marketing material that you are looking for with the help of ChatGPT. Is it all gold? Is it all so fantastic? Of course, there are some pitfalls with the large language models. There is a cost of retraining. I think Brian already mentioned that what they saw to include the more recent data into the vector databases, into the large language models, which are in fact pretty static. Hallucination, what he said as well, they're just going crazy if they're not guided in the right way. They're still trained on outdated information, so only up to the end of 2022, or ChatGPT even only up to the end of 2021. Another thing that we tackled before was the industry or the domain-specific large language models. So the general models do have a lack of specific taxonomy and can help you understand an industry-specific question. And of course, not only related to large language models, but in a general way related to artificial intelligence is bias and ethical concerns what we do have about all these models that are based upon all the information that is available. And a thing, transparency and accountability. How do we understand that from the question we put forward, all the information that went into the large language models, we get this type of answer? So traceability and seeing how all the insights are calculated in large language models is still a big black box. So tools that are available for doing AI and as well interacting with large language models, we get in Canva, which is a visualization tool to create presentations. You can use prompting as well to get the visuals, what you have. Pretty comparable to Mind Journey, not at the same level, but bit easier to get these visuals depending on what you put into the prompts. You have ChatGPT, which is the user interface, very well known to everybody, but you have the playground as well, which allows you to put some more parameters to the large language model and get some more flexibility out of ChatGPT. Other tools that are predictive tools are Cast Magic. That's a tool used for podcasts, for example, where you put in your audio podcast and you can get questions for a Twitter feed, for a LinkedIn post, for writing a newsletter announcement of your new podcast, name it. You can even create your custom prompts. And every time you upload a new podcast, you get these pieces of media out of the product. So that's very productive and very helpful for using these tools. GetMunch is alike to Cast Magic, but it's used for videos, and it creates short videos out of maybe 30 minutes of video based upon the SEO keywords you feed it. It does some research on YouTube, and it gives you the shorts which have the highest potential of going viral. So very productive tools. Otherwise, I think it takes you a few days to get these these outputs just from one video, for example. If we're looking at coding, Copilot is an AI coding assistant for multiple programming languages developed by Microsoft, very productive as well. And GPT Engineer is another coding assistant which is available on the market, and it allows you to just define your project, and GPT Engineer generates all the code for the project that you just specified. And I think that's a bit to wrap up in a nutshell about prompting in large language models, Eric. I didn't pay attention to the time. I think overrun a bit, but you see, we have time to do another full session just on prompting as such. But I'm so excited on what it is bringing on large language models and prompting. So I hope to have inspired everybody a bit on what you can do with the prompting all over the place.
I love it. Yeah, that's a lot of really good material. The tone is important, sequencing, chaining, but being very specific about how you work with these things. Real important stuff. DM Radio is coming up. Stand by.